Bismillahirrahmanirrahim. Welcome to the second part of 19th lecture of Statistics and Probability Theory. We will continue with the topic normal distribution. Let us consider a variable x which is normally distributed with a mean of 100. It means mu is equal to 100 and a standard deviation of 10. Find out the probability 85 less than equal to x less than equal to 110. So we have to find out this probability and let us assume that x1 is equal to 85, this value, and 110 is equal to x2, as these are any two values of the random variable x, as x is a normally distributed random variable and its range should be from minus infinity to infinity. To find out this probability, what you have to do, let's first sketch the bell curve of normal distribution. So this is the bell curve, or you can say normal curve. As the mean is 100, so here will be mean, which is mu is equal to 100. It should be like this. You can draw it again. This is the normal curve, and this is from minus infinity to infinity. The axis is, and let this is x1, which is 85, and this is x2, x should be somewhere here. Now it is 110, so it should be here. This is mu, as we all know, mu is equal to 100, so no need to write it, and this value is 110, and you have to find out this particular area between 2 points, this one. You have to find out this area, or you have to find out this probability. So by using the probability density function, this should be equal to this probability 85 less than equal to x less than equal to 110 should be equal to, from 85 we will integrate the probability density function from 85 to 110, which is 1 over sigma under root 2 pi e raised to power minus x minus mu whole square over 2 sigma dx. So to get rid of this calculation, which is not so easy and will give you the approximate results, we will convert this random variable x into the standard normal random variable, which is z, and which is x minus mu over sigma. By converting the random variable x, or by transforming the random variable x into the random variable z, this will be converted into standard normal distribution, in which mean is 0 and standard deviation is 1. For this purpose, let us assume z1 is equal to x1 minus mu over sigma, and z2 is equal to x2 minus mu over sigma, where we know that x1 is equal to 85 and x2 is equal to 110. By substituting the values, as we know mu is equal to 100 and sigma is equal to 10, we will get z1 is equal to minus 1.5 and z2 is equal to 1.0. So now, by transforming it, we have to find probability minus 1.5 less than equal to z less than equal to 1.0. We will sketch it again for the random variable z. For this purpose, this is the normal curve, standard normal curve for mean 0 and variance 1. This is mean 0 and variance is 1. So the first value z1 is minus 1.5. It should be somewhere here, minus 1.5, and the greater value is, the upper limit is 1.0, which should be somewhere here. So we have to find out this area. So we have to find out this area, but the problem is the table we are using is giving us the area or probability from 0 to some specific point z. But you have to find out the probability from minus 1.5 to minus 1.5 to 1.0. So this is the total area you have to find out, but the table is giving you the probability of area from mean to some specific value z. That is, you can find out the area from 0 to minus 1.5, or you can find out the area from the table from 0 to 1.0, but you want to find out this complete area. So what you will do? You will do this in this way. This will be equal to, let me change the color of the ink. Now this one is good. This will be equal to probability minus 1.5 less than equal to z less than equal to 0. You can write less than or less than equal to, both will give you the same meaning in continuous probability distribution. So this one is this area. Minus 1.5 to 0, but you need this complete whole area. So what you will do, you will add the remaining area plus probability 0 less than equal to z less than equal to 1.0. 0. So now you can use the table minus 1.5 to this from mean to some specific point. This is from mean to value minus 1.5. But as you know, you only have the positive values for the random variable z. But as the standard normal distribution as well as normal distributions are identical and symmetric, so you can use 1.5 instead of minus 1.5. Both will give you the same area, and as it is, this is 1.5, you have to search the column which one you have to select. As this is only minus 1.5, so you will consider the value 0 here, and you will select the column with 0.000, and this one is the value 0.4332. So this is the area from the point 0, that is mean, to some specific point which is minus 1.5. So this area is 0.4332. Now you have to find out this area from 0. It means from mean to specific point z, and this specific point is 1.0. So you will look at the random variable z, which is here, which is 1.0, and as you know this is 1.0, so you will select this column, the column containing the 0 value of the random variable z is 1.000, means so it will be 0.3413. So this will be, this area will be 0.3413 413. So you will add both these areas 0.4332, which is this one, plus 0.3413, which we have done here. We have highlighted this. This area is 0.4332 and this area is 0.3413. So all together this complete area will be 0.7745, which is, you can write it in this way, 0.4332 plus 0.3413, which will be equal to 0.7745. So this is the area between 85 and 110, which is 0.7745.